So let's have a look at SMIGHT's solution to creating smart grids to enable the energy transition. So Ollie, through his experience within the DSO background, can give me a few inputs here as to what are the requirements from a DSO side that we have to meet with our solution.
The first thing is, as I said, bringing out very fast. So we don't have too much time to bring complex solutions in the grid. So it must be fast.
Yeah. So the energy transition requires speed, but also the size of the network requires speed. Again, bearing in mind that the low voltage networks are huge, and therefore we need to be able to roll out quickly. So we focused our efforts on creating a retrofittable solution. So it can go out into all of the infrastructure that's already out there. We don't need to be swapping out anything, creating intelligent substations or anything like that. You can use all the infrastructure you have there. We can just make it smart, very simply and very fast.
And we have to limit the disruption. We cannot cut off whole of the grid.
Exactly. So we need a solution which can be installed whilst the system is running. And that's precisely what our solution does. You can install it while all the power is on. No one needs to be cut off. There's absolutely no disruption.
And it has to be done very easily. So everybody should be able to install devices.
Exactly. The DSOs don't have the resources to be training up a specialist team to be able to do this. So we've really placed an emphasis on making sure that the technicians who are working out in the networks already can install our solution extremely fast, but without any specialist training. This can be done by anyone, and we're going to show you that in a moment.
And as a grid operator, we are afraid about big and complex and expensive IT projects. So it should be a very easy solution on the IT side also.
Yeah, so we recognize that DSOs have got a lot on their plate, and we want to take some of that away. So the solution that we provide is completely end-to-end. We deal with all of the IT back-end, so there's no big IT project to take all this new data that you're collecting from your network and being able to do all the storage, the processing, and so on with that. We deal with all of that. We just deliver the full solution that is quick and easy and fast to install.
Okay, perfect. So let's go one level deeper. Could you show us this installation process?
Yeah, let's have a look at how this works in practice. So this first of all starts back at the office. So what our customers do is they use our device admin to lay out all of their network in the system. So they lay down which substations they're going to be measuring, the feeder information in there, the fuse ratings, the users. They can lay down all kinds of information which is useful for understanding the network. They do all that in a web-based backend. So there's no specialist software that needs to be kept up to date or run on servers or anything like that. It's all done through a web platform. Once that's been done, the technicians can then take our devices out and install them out in the substations and distribution cabinets. This is extremely simple, and we'll show you that in a moment. But through a very simple process with a QR code and a phone application, we're then connecting the data that was set up in the back end to the installation out in the field. And so with this, within 15 minutes, we have the live data available to the DSO. So it really is that quick. The limiting factor is how quickly you can get around your network. So let's move over into our live demonstration. Okay, so what we've got here is just an example of what a feeder might look like, just for demonstration purposes. And so this is our standard sensor that we have here. This is the piece that we call the sensor. And then these are the split core current transformers which are installed on the cables. And so we label all of these up with which phase they should be on, and we also have the direction that they should be installed. And so all the installer is doing is taking these and clipping them round onto the cables like this. So this can be done with the kind of gloves that they need to wearing with all of the other safety equipment. It's a little bit easier for me here with all this space.
It's even easy for you. You're not an expert for such things, but if you do it wrong, so take the wrong phase, or what is happening?
Yeah. So it could easily happen that, as Ollie says, we could have the wrong phase. I could also install these in the wrong direction, and therefore the flow would be incorrect. That's not a problem. So 90% of those cases in the back end of the system, we can first of all identify that and correct it very quickly and simply. We can also identify it and communicate that out to the DSO. That's very simple.
And this can be done live, or you have to cut off the station?
Exactly. So all of this is being done live, and yeah, it's very simple.
On the sensor side, we don't see any installation cable. How does it work?
Yeah, so there's no power cable here, But what they're doing, these devices are energy harvesting. So they're taking the measurements and collecting the energy and supplying that back to the sensor. And then the sensor is transmitting the measurement data to our gateway, and that's then transmitting it out into the cloud. And the advantage of that means that the connection between the sensor and the gateway being wireless means there's no cables being run through the substation or the cabinet, not getting in the way. So imagine that scenario where you're having to go out and do something urgently within the substation and you've got cables everywhere. That would be a real problem. And so we've dealt with that through the wireless communication.
But this is a little bit unfair because it's a much space between the faces. So we prepared another thing. Could you show the same installation in the cabinet?
Yeah. So not only is this a little bit unfair for demonstration purposes, in the real world out there, we don't always have plenty of space to be able to work with. And in addition, we don't always have cables that are this thin. They're sometimes much larger cables. And so we have a second solution. So this is what we call our sensor flex. And this solution uses Rogowski coils, which can be used for much larger diameters. And also this can be used in much tighter situations. So I've brought with us a distribution cabinet, a typical one that you'd find here in Germany, where the situation down in the bottom here is generally much tighter. The cables are closer together. This is usually underground, and it's much more difficult to install. So just like with our other sensors, we label them all up with which phase they should go onto. We also have the direction of the flow. And just as with the other ones, if any of that's done incorrectly, we can correct that in the back end of the system. So I'm just going to lay that inside for the moment.
So you need assistance, or is it can it be done by one worker?
It should be able to be done by one worker. As long as they can do this clicking action, which is fairly simple, they should have no problem installing this. And this is not just in theory. I mean, all of our customers at the moment are out there installing these without any issues. And we have fantastic feedback, which we always collect from the customers as to how easy it is for them.
How many sensors are already installed out there?
So we have in the region of 4,000 gateways, and then sensors on top of that. We're measuring about 100,000 measurement points at the moment out in the
You said gateway, so how is the connection between the sensor and the gateway we see at the door?
Yeah, so as I said before, we have a Bluetooth connection. So the sensor here, this is collecting the measurement information from the cables directly, and this is sending via Bluetooth up to the gateway, and the gateway is sending that up into the cloud.
And you said it's our Rogowski coils.
Yep.
So how is the connections to a power supply in that case?
Yeah, so that's the one downside of Rogowski coils, is that they can't do the energy harvesting. So we've already put in here a power supply, and we work with a company who has these special connections, which means that you don't need to put a socket in. You can connect into the infrastructure very simply within the installation situation. And you can even reinstall all the covers here back onto the devices. And we also deliver the tools required to do that. So the power supply is then connected onto the sensors, and the sensors in turn are connected to one another via a daisy chain. And one can also install a mixture of sensors. So if you had an area which was tighter, you could install some flex sensors, and an area that is a bit more open, you could install the standard sensors. And we can install up to 20 sensors per gateway. And if you needed more than that, you'd simply install 2 gateways.
Okay, looks very simple for installation. So how is about the de-installation process if I like to change?
So this is a situation that we see out in the market, is that sometimes you pick out a substation or distribution cabinet, you perform the installation, and then you find out the loads are just really uninteresting. They're particularly low, they're in line with what you expect, and therefore monitoring it on a continual basis maybe doesn't make sense. And so what I've just done, you can do in reverse. You can undo all the coils, you can take the gateway out, and you can take that to another station and install it there. And again, through the same process with the QR codes and the device admin in the background, you can then move that device somewhere else in your system, therefore enabling you to work your way through your network. And we don't advise people move things around all the time because you lose the trend of data over time. But if you find an area which is uninteresting, there's no point in measuring it. Just keep moving through your network, find the critical points and measure those.
Okay, perfect. So you have already explained what is happening if the worker does the installation on the wrong way, if the current transformer is done on the fault side, or something is done wrong. What is happening below the surface? beside these aspects.
Okay, so it's very obvious to see here what's going on with the physical items. Now we'll just flip back to our system here to show you what's going on beneath the hood. So on the one side, we've got all the data transmission. So we're managing the data flows from the sensors to the gateways and the gateways into the cloud. We're also then managing all of that data storage and all that data backup. And at the same time, having to deal with all the data security issues. So we use a cloud platform, which is ISO 27001 certified, so that your data is always secure. On the other side, we're doing all the administrative work. So we're making sure that all the devices are installed correctly and are operating correctly. So you can have a very simple situation. Maybe someone works in a substation and pulls the plug out from the gateway and it has no power. We can identify that, alert our customer, and therefore they can easily go and correct it. So we're dealing with all those kind of things. And on top of that, we're able to roll out software updates and patches very easily to the whole fleet of devices. I think to appreciate how important that is, imagine doing this all yourself. So imagine you've got a network of maybe 10,000 substations. You want to roll it out to 20%. How many gateways is that? How many feeders is that with sensors? Each one of those is a mini computer out there, which needs to be monitored and needs to be kept up to date. And you need the infrastructure in place to be able to do that. And we offer that all as part of our package, so you don't need to worry about that. That's what we mean by no need for a big IT project to be able to deliver this. We deliver that all. So that's what's happening below the surface. We're keeping an eye on the back end and making sure that everything runs smoothly. But then we deliver the data out into the world. So on the one side, we have our SMIGHT IQ, which we're going to look at in a moment, where we visualize and make the data useful for you. But we also play nicely with others. So our platform can be used via an API to deliver data out to things like flexibility platforms, where, for instance, where you can see where peaks are, exactly where they're happening, when they're happening, and to what extent. That can help enable flexibility to be deployed out in the low voltage network. As we gave the example before with Düsseldorf, you can use the data to validate and sharpen the simulation tools. You could use it in control systems and also in digital twin packages, which are often being used today. So all that data is going out into the world. Let's have a look now at the platform.
Okay, perfect. So you have explained how we can easily install the sensors, how we do the management of the devices, how we can transmit the data, and now let's have a deeper look how we can make this data useful with SMIGHT IQ Cockpit.
Exactly. So I'm inside the cockpit here. This is all web-based. As we said before, there's no need for specialist software. You can log in through any computer that's connected to the internet and access your data. Now, the data that we're going to show you here is real data that we've taken from customers, and we've anonymized it and put it into a map around where our office is. And so what you would first see when you log in is this very much a helicopter view. And with that, you can then identify where there are critical points in your network. So we use a traffic light system, fairly simple. With any given feeder below 60%, the pin for the substation would show as green. Between 60 and 80% it shows as yellow, and anything above 80% is showing as red. We also give a very quick overview of any given feeder that has been a high load. So again, you can quickly from the home page zoom right into the critical points. And we also record the critical events where the threshold has been violated. So where that fuse rating has been gone over. So once again, you can go into a single point in time very quickly from the dashboard.
So what could I do if a pin is red?
Yeah, so let's take one of these red pins that we have on the map here. So I can click into that. It gives me some summary information about the substation. Again, you as the customer are free to label these however makes sense for you, whether that's matching your GIS information or whether you want to label it in some way that makes more sense. That's fine. You can then click into the substation and then you see this summary view of the substation data. And so this again can be played with according to what you need, whether it's looking at different phases, whether it's looking at reactive or active current. You can look at voltage in there as well. And we show all of this information. And just to reiterate, this is live data. The speed with which this system works is exactly the same speed that you would be seeing out there. Now, in our example, we had a red pin, but that's only related to one particular feeder. So I can go one level deeper. So I can click in here to this feeder, and then I can see a series of data here. So I'm going to put back in the main phases here. I'm going to take out the active currents. So again, you can play with this to your heart's content, and we're also going to leave a link to our demo at the end of the webinar, and you can go in and play with this on our website live and see all of how this is working. What we also enable doing is zooming in time-wise. So what I can do is highlight a particular period, and it zooms in. Again, maybe I want to look more at what's happening here. And depending on your needs, you can then play around. And this was the example that we had in our slides earlier, where the customer had particularly high loads and was then able to take a switching action to then pull them back down again.
What are the signs, the yellow and the red signs?
So these are the warning symbols. So we have yellow ones when the kind of minimum threshold is gone over, and we usually set that at 20% below the fuse rating, and the red ones are where the fuse rating has been gone over.
Can I receive an alert?
Yeah, so we have our system set up to send out emails to the addresses that you require as and when these events happen. So you can immediately see a summary, and we also send out a monthly report. So again, you can get this overview of what happened last month where.
And if I have such a situation, what could I do as a grid operator?
So in this particular situation, I can identify here in particular that it's one particular phase which is causing the issue. So I could then maybe go and look in my data and try and see what's connected there and what might I be able to do about it. But what this particular customer did is they went out and did the switching action to take the load and put it onto another feeder.
Okay, perfect. So this is a overloaded feeder, and they did some switching and put the load from this feeder to the other feeder, and they reduced the load on this specific problem feeder. Yep. What's about PV? It's a big issue, not just in Germany. How can I see how PV has an impact on my grid?
Yeah. And so one of the features of the SMIGHT system is being able to see the flow direction, and that's quite important, especially for solar panel installations. So we have a particular example in here to show what this looks like. So it's this one, and I'm going to go into this feeder here. Now, on first look, it looks really uninteresting, and that's because I'm in the winter months at the moment. So I've always got to bear in mind the time window. So I'm going to go and zoom out to a whole year's worth of data. And again, imagine what a whole year's worth of data really means, taking once a minute measurements across 3 phases, plus the neutral line, phase angle, and all of this information being represented in real time this fast. I think for our guys who developed this, it really is quite an achievement. And again, we can start to see through the relative currents here, which I can bring back in. I can take the loads away. You can see the negative flow. So here I can see my 0 line, and then down here, I can see the negative flows. In this particular case, it wasn't critical, but it gives you an idea that we can visualize that. And in some cases, especially on particularly long feeders where you have a lot of solar installations, you can really have a much bigger issue. And so being able to identify those and which direction it's flowing in really is quite important.
Okay, perfect. So you said a smart grid is self-aware and a self-controlling grid, and you have shown in the last couple of minutes how we can bring devices out there, how we can bring hardware out there, and now you have shown us how data can be used to solve a real problem out there. But who is SMIGHT on a company level? Who is SMIGHT as a company?
Yeah, so we've been in this field of using Internet of Things sensors and all of that infrastructure for about 8 years. We're now a team of between 30 and 40 people. And as we mentioned before, we're already working with 120 DSOs around Germany and other parts of Europe. And we have got about 100,000 measuring points already out there. So again, just to really iterate that we're already doing this. This is not a nice concept that we'd like to roll out. This is something that's already in operation at a reasonable scale. It's safe, it's working. And the other thing we want to get across is that we've been working with various different sizes of customers. We can work very well with the larger ones, with their kind of requirements, but also smaller DSOs who have a different set of requirements. And we came out of the EMBW group. So we have this great combination of being a relatively small, agile and flexible company, whilst having significant backing behind us to be able to assure you that we'll be there to be able to continue to support you.
Okay, perfect. Thank you very much. So we have heard a lot. Could you give us a short summary what we have heard this morning?
Yeah. So in the outset, we wanted to really get across this idea of what is the problem faced by network operators. And this problem is this dilemma between two good things that they both need to achieve. And society kind of requires this of them. On the one side, the energy transition needs to happen. On the other side, we need reliable, stable grids. And the network operators somehow need to achieve this. We believe that simply by doing the old technique of reinforcement and building of networks, even if we wanted to, we just couldn't do it. And therefore, we need to implement smart grids. And this in particular needs to be done on the low voltage. A, because it's not been done there already. And B, most of the energy transition happens on the low voltage grid. This is where the dynamic is being introduced. And that's where we need to bring in the measurements. And we believe we have a solution with SMIGHT that is quick to roll out in retrofit, is very simple to use, and is very effective at bringing that transparency into low voltage networks. And it's one that can be deployed today at scale without any difficulty.
Okay, perfect. And if I'm interested in this solution, how can I get in touch with SMIGHT?
Okay, so we have the usual channels. You can go and view our website. We've got the links here on the slide. We have the demo, which we just went through. You can play with yourself if you're interested in looking into a little bit more detail of the data that we're capturing. We have our LinkedIn. We're happy for you to get in contact with us there. And really want to call out to all the DSOs out around the world and other companies working with DSOs to please get in contact. We're trying to roll this out beyond the borders of Germany. And we really want your help, and we want to get into contact with you so that we can support you to bring transparency into the low voltage grid. So please do get in contact.
Perfect. So thank you very much, Dirk. Thank you very much, everybody, for listening to us. And please get in touch and let us trying together bringing the energy transition and digital grids together. And we like to help you, and we would appreciate very much if you get in touch with us. Thank you very much. All the best. Bye.